Hello everyone and welcome back to part 6 of the Blueprint Basic tutorial series. Before adding something new to our hovercraft, let's first fix a few issues that appeared after setting up the random hovering in the last episode. Because the platform is now rotating around the X and Y axis, its forward vector no longer points only in the direction we want to fly. It also points slightly up or down. So, when the platform moves forward, we either lose or gain altitude. Let's fix that. Go to the forward movement block. Disconnect the Z location pin from the set world location node. Instead of using the Z value from the forward vector, we simply keep the original Z location. To get this value without splitting all pins, drag out from the return value of the Get World Location node and search for Break Vector. Then connect the Z output to the new Z location pin. Now the platform keeps its altitude, no matter what X or Y rotation it has. The next update goes to the up and down movement. Do you remember the blocking sweep? Until we set the hovering rotation back to 0, 0, 0 at a height over ground less than 50? Well, that works for most cases when landing on a flat surface. I tested our hovercraft blueprint in different levels, and it shows the sweep could easily be blocked by uneven ground. And here is the fix. At the end of our up-down movement, we simply check if the sweep hits or not. To do that, drag out the sweep hit result pin of the set world location node and search for break hit result. Then add a branch to the blocking hit pin. If there is no hit, so the condition is false, just connect it to the platform rotation call. If there is a hit, we simply add a very small value to the Z location of the platform to lift it up outside the sweep block area. Add a set world location node for our platform to the true pin of the branch. Also add a get world location node. Split the pins, connect X and Y directly and add 0.2 to the Z value. Leave the sweep checkbox off. This way our hovercraft lifts up a tiny bit when the sweep is blocking the up movement. Finally, connect the output pin to the platform rotation call. And now you can land the platform everywhere and lift off again to 100%. Okay, today we will add a cockpit camera to the platform. And we want a smooth animated transition between the cockpit cam and the player's follow cam. So first, add a new component to our blueprint. Search for Camera and use the first one in the list. This is the standard camera and it's the same camera type as the player's follow camera. Name it Cockpit Cam. Go to the level viewport and select the hovercraft blueprint. Now you should see the camera's preview. If not, go to the camera's options menu and check Preview Selected Camera. Now find a nice position for your cockpit camera view. If you want to use the same values I am using, its location is 350, 0, 225, and the rotation is 0, -8, and 180. Also, I like to change the field of view. The default 90 degrees looks a bit too much like a GoPro wide-angle lens. I prefer a more natural look and use 50 degrees. Okay. Let's set up the cam switch logic. In the event graph, add a new keyboard or gamepad input. Connect a branch to check if the cockpit cam is currently on or off. Create a new Boolean variable for that and connect it to the branch. Then create a new custom event and name it Enter Cockpit Cam, for example, and call it from the fold pin of the branch. Drag out the pin and search for Set View Target with Blend. This node allows us to smoothly blend from the current view to a new camera view. The target is our player controller. So we connect a getPlayerController node here. The new view target is the actor that owns the camera we want to use. Because our cockpit camera is inside this blueprint, we can simply use self. Blend time controls how long the camera transition takes. For example, 0 means an instant cut. Let's try 1 second. Blend function defines how the transition is animated. Leave it at linear for now. You can play around with these settings later. The blend exponent controls how strong the curve is if you use an ease curve. And lock outgoing decides if the old camera should be frozen during the blend. Turn it on to prevent the follow camera of the player to move during the transition. Then set the created Boolean variable to true. Now we create a similar logic to switch back to the follow camera. Create another custom event and name it Exit Cockpit Cam. Call it if the blend condition is true, so the cockpit cam is active. Copy and connect the whole logic we just created to the exit event. Set the Boolean to false, and as the new view target, we use the player character. Remember, this is the character blueprint that contains the follow camera, not just the character mesh. Oh, here I accidentally used the wrong node. That can happen sometimes, because there are often multiple nodes with the same name but different purposes. I added getPlayerController under state instead of game. So, if you get any errors, this is definitely something you should check first. As you can see, it works. But if we exit the cockpit cam, it blends back to the player's camera position. And if you move your mouse while the cockpit cam is active, the position changes even more. Let's try to give the player camera a new specific position before blending back. For that, we need to create a small custom event inside the character blueprint. Open the character blueprint, go to the event graph and create a custom event. Name it Reset Controller. Because we want to set the follow camera in relation to the platform, we create a new variable. Name it Platform and set the type to our hovercraft blueprint. To initialize this variable, we use a getActorFromClass node and select our hovercraft blueprint. This node searches the level and gives us a reference to the hovercraft actor. We store this reference in our platform variable. Now we can access the rotation of the platform and use it to reset the camera. Split the pin, because we only need the Z rotation. Add a setControlRotation node after setting the platform variable. This node sets the rotation of the game controller camera, which means the player's follow camera. So add a getPlayerController node to the target pin. Split the new rotation pin. I want the camera to be straight behind the hovercraft after switching back. So leave X and Y at 0 and add 180 degrees to the Z value of the platform before connecting it to the new rotation Z pin. OK, now we can call this event from our hovercraft blueprint. To do that, we need to open a kind of communication channel to the third-person blueprint. Search for cast2bp_third-person character. This allows us to access functions and events inside that blueprint. The object is the player character. Now we can call the Reset Controller event and connect the target to the BP third-person character pin. Insert this right after the Exit Cam event. OK. And to prevent the player from accidentally falling off the platform during cockpit mode, we should disable the input controls when entering the cockpit camera. So add a Disable Input node at the end of the Enter Cockpit Cam block. Add the player character as the target and the player controller to the controller pin. Also add an Enable Input node at the end of the Exit Cockpit Cam block. But add a delay node with the same duration as the blend view node to protect the blend animation from input controls. Now we can switch between the gameplay follow camera and our cockpit camera. And after blending back, the follow camera is always exactly where we want it to be. And that's it for today. See you on the next part. Cheers!